Okay, so we're going to be looking at IA3, or sample IA3. So this is the tech-free section. Okay, so the length of a human pregnancy has a mean of 266 days and a standard deviation of 16 days. A random sample of 9 pregnant women, so that would be our trials, or N, is equal to 9, was observed to have a mean pregnancy. Now this is the mean of the sample, 270 days. I'm just going to write women next to that so I remember. And a standard deviation of 14 days. Okay, identify the parameters and accompanying statistics in this situation. Use mathematical reasoning to justify your response. Okay, so parameters go with the population and statistics go with the sample. So if this was our population data here, that's the population, therefore that's the parameters. And over here, this is the sample. So then that relates to the statistics. So I'm guessing what they mean by some mathematical reasoning to justify your response is putting that in Word. That population data refers to the parameters and sample statistics refers to, well, the statistics that go with the sample. They may have noted this down as the mean of the sample data, and this one would be the standard deviation of the sample data, whereas this would be the mean of the population, and this would be the standard deviation of the population. So the difference could be the little hats. I would go through and just double check what QCAA have done for that, because that's kind of one of those questions they throw in there to sort out, your top ATAR rankings. So it's kind of like to check and see who bothered to read the textbook, I guess. Okay, question 2. Determine the exact value of the constant k if the function below is a probability density function. So if it is a probability density function, that means when I integrate it between our lower and upper bounds, it should equal 1. So 1 should be equal to the integral of ke3x between 0 and log e2. Okay, now next thing I'm going to do is integrate our function. So k is a constant at the front. When I integrate e to the 3x, I take the derivative of 3x, which will become 3, and it's going to be divided by that. So that's my new function, 0 log e2, and that's still equal to 1. So now we're looking for the value of k that makes this statement true. So I'm going to substitute k over 3, so e to the power of 3 times log 2 minus k divided by 3 e 3 to the power of log 0. Oh wait, not even log 0, it's just 3 times 0. Now, when you guys do this, it's a great idea to put brackets around these things, because otherwise you let the negative symbol do whatever it wants. You don't take account for it, so just be careful of that. Okay, so let's start sorting this part out. So k over 3. So first thing I'm going to do is move this back up, so it'll become e log 2 to the power of 3 minus, now that's log with base e or ln, minus k over 3, e to the power of 3 times 0, so 3 times 0 is 0, e to the power of 0 is 1, so we're just left with that. Now I can start looking at this section here. Now, this has the same base, meaning I'll just be left with 2 to the power of 3 there. So now this is going to become, because that's knocked out, that's 1. K over 3 multiplied by 2 to the power of 3 is 8 minus K over 3. It's going to be equal to 1. Let's do this working over here. 1 equals 8K over 3 minus K over 3. Look at that, nice denominators. Because they've got the same, I can just subtract them. So that's going to become 7K over 3. Take this 3 up and multiply. Take the 7 down by dividing. And that is my value of K. Okay, calculate the expected value for a uniform probability density function defined on the interval. Okay, so for this one, we're going to need a formula. So the formula that we're going to be using is, now, the continuous random variables. Now, the thing that tells me that is because this is a uniform probability distribution, and this isn't like discrete values. This is a function, and it's one function all working together, meaning that the area underneath this is 1. Gary, stop stretching. So if I'm graphing this, it'll look, when I graph it, here's my boundary, 20, 70. Up here, this value here will be 0.02. So it's uniform, meaning it's always that value. The area underneath here will be equal to 1. So let's just start working out our expected value. Like I said, it's going to be a continuous random variable. Okay, so that means that the formula for this, for the expected value, is equal to, and this is in your formula sheet, you just need to use your little eyeballs to look at it, the integral of 20 up to 70 x multiplied by our function p of x, and so I'm just going to input our function now, 0.02 with respect to x. Okay, so when I substitute this in, that's going to give me, now I expand the brackets and then I'm going to integrate in one step. So 0.02x, when I integrate that, it'll become squared, so we'll divide it by 2, and that'll give me 70 over 20. Now this one will cancel that one to make that 1, so I'll be left with 0.01 x squared 70, 20. Now all I have to do is substitute my values into the function. So 0.01 70 squared minus 0.01 times 20 squared. Now I know in class you'll be tempted to grab your calculators, but remember this is tech free, so we've got to do the hard work. So this is going to be equal to 0.01 multiplied by 4,900. Now if you're not sure about your decimals, you get confused with this, just chuck a little sum in. 0 times all of this will just be 0. Next one, you always start with a 0. 7 times 0 is 0, so it's 49. Okay, minus 0.01 times 400, which is 20 squared. Now, when I'm moving my decimals, I'd move my decimals twice here, meaning that this is going to come forward twice there. And then when I move it twice here, it'll come forward twice there. So this sum becomes 49 minus 4, which is 45. So therefore, the expected value of this function is 45. Now, another way that I could test this is because this is uniform distribution. Okay, so your mean is the average value, and because this is uniform, your mean and your median are going to be the same. It's going to be halfway between them. So if I do 70 plus 20 over 2 is going to be 45. Okay, and that would prove that that one's correct. Okay, so let's do question 4. Okay, so a point of inflection that is also a stationary point, sometimes called the horizontal point of inflection. Let y equal this, determine A and B given that there is a horizontal point of inflection at x equals 1. So what this is actually saying to us, this is our graph. There's a horizontal point of inflection at x equals 1. Let's just say here's the point there. This is going to either look like this, or it's going to look like this. Okay, but either way, at that point here, that is when our gradient is equal to 0. And if it's a stationary point of inflection and also a horizontal point of inflection, that means the second derivative is also going to be 0 at the point when x equals 1. So they are the two statements that we're given so that we can work through this. Up this for a little bit. Okay, so first things first, state my function. Y equals x cubed plus ax squared plus bx minus 1. Won't give you any extra marks. I just like to state things. So then we take the derivative of it is equal to plus 2ax when we take the derivative plus b. Next one, double dash, take the derivative of this function, 6x plus 2a. Okay, so now I can start substituting in here so that we can rearrange and solve. So the first thing I'm going to do is let y double dash equals 0. And I'm starting with y double dash because there's less stuff. So y double dash equals 0 when x equals 1. So 0 is equal to 6 times 1 plus 2a. So 0 equals 6 plus 2a. Take the 6 across, it'll become minus 6 is equal to 2a. Take the 2 across by dividing, and you'll be left with negative 3 equals a. Okay, if I'd started with the other equation first, it just means that I would have had to have gone back and put that in later. So the next thing, we're going to go to y dash. Now we're going to input what we found. So 3x squared plus 2 times negative 3x plus b. Okay, now we're going to let y dash equal 0, and we're going to let x equal 1. So 0 is equal to 3 times 1 squared plus negative 6 times 1 plus b. So 3 minus 6 plus, I'm going to start doing that as a capital because my handwriting looks like a 6. There we go, equals negative 3 plus b. So when I take this to the other side, it'll become positive 3 is equal to b. So therefore, now it's only asked us to determine a and b, so I don't have to state it back in the equation. So it's always important to actually read your questions once you finish answering them, because you guys have a terrible habit of doing whatever you want.